torque on dipole placed in uniform electric field. So here we are going to find the value of torque when the dipole is placed in a uniform electric field. So okay, why is the torque acting? If you see, if this is the direction of electric field and we have placed the dipole in this way, then if this is the direction of electric field, then we have to assume here are some positive charges and here are some negative charges, and electric field originates from the positive charge and it's terminating at the negative charge. Now this positive charges will definitely attract this, okay, and this negative charges will definitely attract this positive. So this which is aligning in this direction, it will turn and it will be aligning in this direction. So that is what we can say. So if this is in this way, then it will turn around and it will be aligning in this direction. So we can say a torque is created. Okay, now how we are going to find the torque? The general formula for torque is R bar cross F bar. So R is nothing but the length and F is nothing but force. We will see it, we will study it later. So yes, so we have to take the force. If this is the force, okay, please see this one. If this is plus Q and this is the direction of electric field, then the force on this plus Q equals to QE. Similarly, on the force on the minus Q will also be equals to QE. And you please see the direction of force on plus Q will be along the direction of electric field, and the direction of force on minus Q will be in the opposite direction of electric field, because here plus charges will attract in this way. So that is the reason. Now we were studying about torque. So if this is the force, if this is the direction of force, then we have to take the length which is perpendicular to the direction of force. So that is responsible for the torque. Okay, so here we can see this is 2L, so this is theta, so this is 2L cos theta and this is 2L sin theta. So which length is responsible for torque? 2L sin theta is responsible for torque. If you see, this is the direction of force, so we have to take the component which is perpendicular to it. So this is 2L sin theta. So what I can write, torque is equals to PE sin theta. Okay, so here P is nothing but 2QL E sin theta. So this is nothing but, it is simple, QE into 2L sin theta. QE into 2L sin theta. That is what I have shown. So there is nothing but 2QL is nothing but P. So P is sin theta Newton meter. So that is the formula for torque. And when torque will be maximum? So torque will be maximum when sin theta equals to 1. So when sin theta will be equals to 1, theta equals to 90 degree. So at that time, torque will be equals to PE, that is tau max equals to PE. So please remember that. Electric dipole placed in different cases. Now let us see. So in the first case, I have shown a non-uniform electric field. So here if you see, there is a less denser electric field line. So here it is a more denser line. So it is like this. So it is a non-uniform electric field. And in the second case, I have shown for a uniform electric field. Previously, the formula which we have seen, that is we have concluded it for uniform electric field. Now we have to just know what happens in non-uniform electric field. Now let us try to learn that. So in non-uniform electric field, definitely there will be a torque acting, because it is displaced from this position. If it is displaced, then torque will definitely act. Okay, so torque is present. Here net force will also be present. So if you take uniform electric field, the net force will be 0, because if I am keeping the dipole like this and here it is minus Q and here it is plus Q, then because of electric field, the force on this charge will be in this direction, that is QE, and force on this charge will be also QE, that is in this direction. So they are equal and opposite. So the forces cancel each other. The force is 0. If it is uniform electric field, force on the dipole will be 0. But we have seen the torque will act. Okay, definitely torque will act. Now, also we should remember one more thing. What is the formula I have told for torque? It is PE sin theta. If in case theta equals to 0, that means sin theta equals to 0, then PE into 0. So at that time, when the theta equals to 0, torque will be 0. So at that point, there will be no torque. Okay, that is what I have told. So in uniform electric field, there will be a torque, but it will be 0 at theta equals to 0. So this is except theta equals to 0, where all other points, all other angles, you will have the torque experienced. Okay. So if there is torque, so torque is responsible for rotational motion. So there will be a rotational motion because of that torque. And this is also for except theta equals to 0 only. Okay. Now let us see this case. So here it is non-uniform electric field. So here it will be plus q, here it will be minus q. So if this space has having electric field E1 and if this space has electric field E2, then because of this electric field E1, what will be the force on this q? This will be q E1. And because of this, what will be the, because of electric field E2, what will be the force? This is q E2. So E1 and E2 are different. So the net force will have some value. It is not 0. So it is Q E2 minus E1 or Q E1 minus Q E2, whatever. But there will be net force. So here, when it is a non-uniform electric field, both force is also present, torque is also present. Okay. And please see that torque is also present for all the cases except theta equals to 0. Okay, but in general you have to remember, if it is non-uniform electric field, then both net force and net torque acts. If it is a uniform electric field, only torque will be there and the force will be equals to 0. And please see this one, here I have told there will be a net force. So because of that net force, so that the net force is in this direction, in somewhere in this straight line, it will be in one direction. So I can say there will be a translational motion because of that force. And because of the torque, again there will be rotational motion. Again, that is for except 0 condition, except theta equals to 0 condition. Now let us see about the equilibrium conditions. So equilibrium conditions are nothing but the conditions where torque is 0. Again, there are two types of equilibrium, stable equilibrium and unstable equilibrium. So let us see that. So if this is the direction of electric field and if our dipole moment is in this direction, so here it is minus, here it is plus, and the dipole moment is directed from minus q to plus q. So if this is one case and this is another case, so this is the direction of electric field and the dipole moment is directed in this way. Okay, it is in the opposite direction. So here minus is there, here plus is there. Now we call, so this angle, what is the angle made by the dipole moment with electric field? It is 0. So if both are at same line in the same direction, so we can keep it like one over the other. So the theta will be, the angle between them will be 0. But what is the angle in this case? So electric field is in this direction, dipole moment is in this direction. So the angle is 180 degree. Okay, so here there is some angle, so here there is no angle. And please note one more thing, this I am talking for uniform electric field case only. So if it is uniform electric field, then definitely force is 0 always. Yes, please note that. Okay, now let us see why it is stable and why it is unstable equilibrium. So when theta equals to 0, if this is the case, then here tau is 0. Definitely torque is 0 because PE sin theta. PE sin 0. This total torque is 0 because sin 0 is 0. Even sin 180 is also 0. So in both the cases torque is 0. Now here you see, here the positive charges are located because of this electric field. We can say here there is a positive charges and here there are negative charges. And if this is the direction of dipole and here it is minus, here it is plus. That means it is already in the stable condition because this plus charges will attract this minus and this minus charges will attract this plus. Yeah, yes, so yes, there is no need for any changing directions because it is already stable. This positive charges are attracting this minus, so here there is an equilibrium condition. Here also it is same. So it is in stable equilibrium. While you see in this case, so here it is positive charges and here it is positive. Here there are negative charges and here is negative. So because this positive will repel this positive and this negatives are repelling this negative. So there is instability. So yes, so this is called as unstable equilibrium condition. Okay, so here you can see plus is attracting minus, here you can see plus is repelling plus. So here it is stable equilibrium, here it is in unstable equilibrium. So what you have to remember, if theta equals to 0, then tau equals to 0. And yes, if you want, you need you can just draw the case of the time of question, and if you want, you can check it at that time also. If this is the case, it is stable equilibrium, that is theta equals to 0. If this is the case, theta equals to 180 degree, then this is unstable equilibrium. Potential energy of a dipole. So the general formula I have shown, it is minus pe cos theta. Okay, what's theta? It is the angle made by the dipole moment along with the angle made by the dipole moment with the electric field. Okay, so it is electric field and it is dipole moment, so that is what is theta. Now the general question asks this: what is the work done? So if I want to know the work done in changing this dipole moment from theta 1 to theta 2. So already it was in some angle theta 1, and I am wishing it to change it to into theta 2. What is the work done in this process? So general is that is asked. So we know work done equals to potential energy final minus potential energy initial, u final minus u initial. Okay, so what is u final? It is minus Pe cos theta 2. So the general formula is minus Pe cos theta. U final means minus Pe cos theta 2. Minus, what is u initial? It is minus Pe cos theta 1. So it is nothing but Pe cos theta 1 minus Pe cos theta 2. So this is how you have to find the work done. So if this is the table, conclusion table, yes, if theta equals to 0, then torque is equals to Pe sin theta, so Pe sin 0 is 0. What is u? That is minus Pe cos theta, minus Pe cos 0 is nothing but minus Pe. If theta equals to 90, tau is nothing but Pe sin theta, so Pe sin 90 will be 1, so it is Pe. U is 0 because minus Pe cos 90. Cos 90 is 0, so that is 0. If theta equals to 180 degree, torque is equals to Pe sin 180. Again it is 0 because sin 180 is 0, and U is minus Pe cos 180. Cos 180 is minus 1. So this is minus Pe cos 180 is minus 1. So minus into minus plus Pe. So this is the value of potential energy. So again we have already seen, if theta equals to 0, it is at stable equilibrium. If theta equals to 180 degree, then it is at unstable equilibrium.